In problem number 2, we have an air standard dual combustion cycle with a mean effective pressure of 10 bar. The minimum pressure and temperature are 1 bar and 17 degrees Celsius respectively, and the compression ratio is 16:1. Calculate the maximum cycle temperature, T4, when the efficiency is 60% and the maximum cycle pressure is 60 bar. So, given itong mga values na yan, yung mga conditions, how are we going to solve for T4? So, pwede natin gamitin yung TS diagram as a guide. Mahalaga yung TS diagram, yung PV diagram kapag nagsosolve tayo ng mga cycle kasi kahit hindi tayo magsaulo ng formulas, pwede naman nating makuha yung concept through the diagrams. So, analyze lang natin. Hinahanap si T4. Kung pupunta tayo sa process 3 to 4, para ma-solve natin si T4, kakailanganin natin ng condition sa point 3. And meron naman tayong P3 dito. Pero, process 3 to 4 is isobaric. So, ibig sabihin, ang temperature is directly proportional sa volume. So, kailangan natin ng V4, kailangan natin ng V3. However, wala naman tayong V4 and V3. Wala rin tayong cut-off ratio. So, paano pong gagawin natin? Try natin sa process 4 to 5. So, yung kaninang in-explain ko is, kung T4 over T3 equals V4 over V3 yung gagamitin natin, di ba itong V4 over V3 is equal sa cut-off ratio. And wala tayong cut-off ratio. Wala ring volume, wala ring V3. And, paano natin masosolve ngayon si T4 kung madaming walang values na ito? Kung pupunta naman tayo sa process 4 to 5, so T5 is T4 over RE raised to K minus 1. So, wala tayong T5, wala rin naman tayong expansion ratio. So, paano natin isosolve si T4? Pero, kung titingnan natin mabuti yung mga given, meron tayong mean effective pressure. May condition sa point 1, may RK. So, kung given yon, diba, mean effective pressure is work net over V1 minus V2. So, kung meron ito, we can solve for work net. And meron tayong efficiency na given. Kung natatandaan nyo, efficiency is work over QA. So, kung meron tayong efficiency, may work net, pwede nating ma-solve si QA. And QA is QX plus QY. And QX is CV times T3 minus T2. So, pwede nating ma-solve si QX. What about QY? QY, pwede nating ma-solve kasi QA minus QX is QY. And QY is CP times T4 minus T3. So, kung may QY, may T3, pwede natin ngayong ma-solve si T4. So, ang gagamitin nating relation ay sa mean effective pressure, efficiency, at saka sa heat added and heat added sa isometric process and heat added sa isobaric process. So, let us start by getting the values of T2, T3 kasi kailangan natin yan, and work net, V1, V2. Okay. So, start tayo at process 1 to 2. At process 1 to 2, the process is isentropic. So, si T2 is equal sa T1 times RK raised to K minus 1. Substituting the values, T1 is 290 Kelvin, RK is 16, K is 1.4 minus 1. Solving for T2, ang value ni T2 is 879.1156 Kelvin. Now, solve naman natin si, ano pang kailangan natin isolve dito? Si P2. Kailangan natin si P2 para ma-solve natin yung T3. So, P2 is P1 RK raised to K. Substitute the value, 1 bar ito. Mamaya, magagamit natin yung P1 sa pagkuha ng, anong tawag dito? Yung specific volume 1. So, i-convert natin yung bar papuntang kilopascal. And 1 bar is equivalent to 100 kilopascal. Substitute lang natin. Yung 1 bar na lang muna. Kasi si P3 ay naka in terms ng bar. RK, 16. K is 1.4. So, P2 is equal to 48.5029 bar. So, bar pa ang unit nito. Okay? Then, punta tayo ngayon sa process 2 to 3. At process 2 to 3, meron tayong constant volume process. So, ang relation natin dyan, T3 over T2 is equal to P3 over P2. So, kaya natin sinolve kanina si P2 in terms ng bar kasi si P3 dito naka-in terms ng bar. Solving for T3, equal siya sa T2 times P3 over P2. Substituting and getting the final answer, we have 1087.5 Kelvin yung lumabas sa sagot after substituting. Then, meron ng T3, T2, P2. Ano pa yung kailangan pa nating ma-solve? Yung V1 and V2 para sa pagkuha ng work net sa mean effective pressure. So, solve natin si V1. V1 is RT1 over P1. Substitute natin. So, R is 0.287. So, the reason why kailangan kong i-convert yung pressure to kilopascal kasi yung ating unit ng R is kilojoules per kilogram Kelvin. T1 is 290 Kelvin. P1 ay 100 kilopascal. Kilonewton per square meter. So, ang 0.287 may unit na kilojoule or kilonewton meter per kilogram Kelvin. So, naipakita ko na naman to dun sa mga ilang examples. Ang lalabas na unit dyan for specific volume is cubic meter per kilogram. So, we have 0.8323 cubic meter per kilogram. Now, solving for V2, kakailanganin rin natin siya. Si V2. So, V1 over RK. Substitute 0.8323 divided by RK na 16. Si V2 ay equal sa 0.0520 cubic meter per kilogram. Now, ang gagawin ko lang, ililipat ko lang tong mga values na to sa sunod na papel. Okay, so now nailipat na natin yung mga values na to sa isang malinis na papel. Solve na natin si work net. Paano po isosolve? So, meron tayong mean effective pressure is equal to work net over V1 minus V2. Dahil meron namang given na mean effective pressure which is 10 bar, so i-convert lang natin to into kilopascal. Again, 100 kilopascal is equivalent sa 1 bar. Equal sa work net divided by V1, 0.8323 minus V2, 0.0520 cubic meters per kilogram. So, ang ating magiging unit dyan is kilojoules per kilogram. And our answer, work net, is equal to 780.2813 kilojoules per kilogram. Now, let us use the formula for efficiency in order to solve for QA. So, ang ating formula efficiency is work net divided by QA. So, QA is work net divided by efficiency or 780.2813 kilojoules per kilogram divided by efficiency which is 60% or 0.6. And QA is equivalent to 1,300.4688 kilojoules per kilogram. Now, ano nang sunod natin gagawin? Solve natin si QY. Diba QA is equal to QX plus QY. So, para ma-solve natin si QY, kailangan natin ng QX. And QX is CV, dahil wala naman tayong mass, kaya CV na lang, times T3 minus T2. Then, substitute. CV is 0.7186. T3 is, ilan pa si T3? T3. 1087.5 Kelvin minus T2 879.1156 Kelvin. So, QX in kilojoules per kilogram is 149.745 kilojoules per kilogram. Now, pwede nating isolve si QY kasi QY is QA minus QX. So, 1,300.4688 minus 149.745. QY, therefore, is 1150.7238 kilojoules per kilogram. So, dahil may QY na tayo, pwede na natin gamitin yung formula. QY is CP times T4 minus T3. Okay. So, QY, again, is 1,150.7238 kilojoules per kilogram. CP is 1.0062 kilojoules per kilogram Kelvin. T4, yun yung maximum cycle temperature, yung unknown, minus T3, 1,087.5 Kelvin. So, cancel ang kilograms, kilograms, kilojoules, kilojoules. Ang ating unit ng T4 is Kelvin. Okay? So, si T4, therefore, is equivalent to 2,231.1333 Kelvin. So, this is our final answer. If you have questions, pwede nyo akong i-message through LMS or through my messenger. So that's all. Thank you.